Okay, so create the table that it'll take that shows the time it'll take her and her team to get from Yonkers to each town. So we're leaving Yonkers and we're going to all these towns, okay? So we have to start with how many miles? 100. And then how many miles do I count by? 100. So 100, 200, 300, and 400. That's what we have in the first table, right? Now we got to figure out how long it takes to get to each town. What do we know, Julie?
We know that 408 on
We know that our ratio is 8 to 400. So for 400 miles, it takes 8 hours. Yes, ma'am?
I figured it out.
Okay, just a second. Now, can we figure out what we need to count by in the hours column? Ricardo?
2.
Now, do you know that or is it a guess?
Because 2, 4, 6, and then once you get to 8 to 400, it's 8.
Okay. Julie?
You could divide both by 4.
Okay. Okay. Kalia? I could divide 400 by 8 and I would get 50. So you're telling me to go from 8 to 400, I need to multiply by 50, right? Is that right? So, Ricardo and everyone else that had their hand up, go to Sonny. You will turn out to be right. It is 2, 4, 6, 8, but that's a guess because you don't have another number to make sure that you're correct. Okay? So you want to always have a pair of numbers to find a relationship. We have a relationship here. We know we're adding 100 all the way down. But we don't know for sure what we're adding over here. Okay? What?
You can try to find multiples of 8 that can get most boxes.
Well, what we did was we found the relationship of the two numbers we have going across the table. So now we can use that relationship to fill in the rest. 300 divided by 50 is?
6.
Yep. 20 divided by 50.
4.
And 100 divided by 50.
2.
Now we're supposed to extend the table, so fill in the rest, to describe how long it's going to take to get to their destination and then make stops on the way back. So we're still just adding 100 every time they make a stop on the way back. So we're still counting by 100s. Yes, Jordan?
I noticed something.
What'd you notice?
That all those numbers on the right are half what the numbers of hours are. Because 500 is half of 10.
Yeah.
600 is half of 12. 700.
Can I tell you why?
Yes, you can.
Because 50, thank you, because 50 is half of 100, and we're adding 100 every time here.
Okay.
So for every 100 that we add, yeah, exactly. That's cool. That's awesome that you noticed that. Okay. Okay, so I need to divide by 50 to find out all of these numbers, right?
Yeah.
I don't have to now, because now I have an easier relationship, which Ricardo guessed, but got proved correct, right? Which is that we're adding 2 all the way down. So I can just count by 2s. 2, 4, 6, 8.
10, 12, 14, 16.
Okay. There's everything we need to know about how long it takes to travel what distance. Now, turn the page. We're working with the same data. So, what was our simplest ratio on the front page?
Oh.
Okay, Leah? 2 to 100. So we're filling in the number line diagram right here to show how long it will take Kelly and her team to travel. This is exactly the same. The wording is exactly the same. It just says use a number line, double number line, instead of a table. So if this is hours and this is miles, what do I start with? Says here,
Hours you start with 2.
And miles?
100.
Yeah. I'm going to do the same thing, right? Count by 2s on top and hundreds on the bottom. So go ahead and fill in your diagram. Okay, using the information from the double number line diagram, how many miles would be traveled in 1 hour? How many miles in 1 hour? Kalia.
50.
50, how do you know?
Because it's like how 2 times 50 is 100, 1 times 50 is 50.
Right, so you can just divide 2 by 2 or cut it in half to find 1, right? So there's our 1. Whatever we do on top, we have to do on the bottom. So we divide our 100 in a half to find 50. And that's how far you can go in 1 hour. So how do you know? Jordan, can you tell me how you know?
Yes.
Go ahead. You need to phone a friend?
Yes, I need to phone.
Go ahead.
I want to call.
Someone answer the phone.
I am.
Quickly.
Tony.
Go ahead, Tony.
Because how you got 50 was since you divided 2 hours by 2, you're going to divide 100 by 2.
Exactly. We found 1 by dividing 2 by 2. So we divided 100 by 2 and found 50 miles.
Thanks, Tony.
Yes. Oh, sure. Thank you.
Fix the lights so I know I'm writing.
Thank you.
Okay. Make sure you have that written down.
Raining. Nope, nope, you're working. Nope. Okay, example 1. We're going to use the same information. Okay? So the same data that we have. We're going to do something different with those numbers. Now this time, dinner service starts once the train is 250 miles away from Yonkers. What is the minimum time the players will have to wait before they can have their meal? So all we need to do is rearrange this data into a table. Yes, sir? Yes?
I don't know if this is an answer.
It's okay.
But since you know how 1 was 50,
Yes.
so
So, Davian, you're exactly correct. You can look at the number line to find out how many hours it takes to go 250 miles. You can absolutely do that. But I want to teach you one more way. So I love that you want to just jump in here and find it. But we're going to learn one more way to find it. And that's by graphing it. Okay? So hours and miles. We just need to rearrange our data back into a table. So in 2 hours, how many miles? In 3 hours, oop, I'm sorry, should be 4, we're counting by 2s. 4 hours,
200,
6 hours,
300,
8 hours,
400,
and 10 hours.
500.
Now we need to write are ordered pairs. What is an ordered pair? Leilani.
Like X and Y?
Yes, like X and Y. But what does that mean? An ordered pair is what, Shay?
It's kind of like ratios. It's like
It's kind of like a ratio because the two numbers are what? Davian.
Oh, well,
What's an ordered pair, Davian?
it's where one number you have to count on the bottom of the
Mm-hmm.
thing, the plot, and then the second number you count is as much as you count up.
Yes. So your x-axis tells you your first number. Your y-axis is the second number. That's right. Why can we plot them like that? What about those numbers, Persephone?
oh, I don't answer that.
That's okay.
I just noticed something.
What'd you notice?
That for how many hours is half a mile?
Mm-hmm. Yeah, we talked about that because every time we add 100 miles, remember I told Jordan, it's because we're multiplying by 50. We're multiplying by 50. Yeah. Okay. Okay, so an ordered pair is two numbers that are what? Random, unrelated, what, Leilani?
That like in graph?
Yeah, we can graph them. But why, Kaylia?
Because they're ordered.
They are ordered. Order matters, just like a ratio. You can't write them in the wrong way or won't get the right answer. But the two numbers are related. The two numbers have to have something to do with each other, right? They're not just two random numbers for no reason.
I think this is my
We're plotting numbers that are related because in 2 hours, the train goes 100 miles, so it's related, okay? Now, how can I write this as an ordered pair? Cecile,
2 and 100.
2, 100. Which one goes on the x-axis? Say it. 2. And which on the y?
100.
Why?
Oh, hey.
Kalia.
because they're ordered.
They're ordered, yes.
They're, so like it's on the I don't know.
It's okay, Persephone.
Because there's X over hours.
Because we decided that these were going to be our x values and these would be our y values. Now there is a reason why we decided it this way. The first reason is when you have a problem that has a variable of time, so hours, minutes, seconds, days, months, years, anything like that, it usually goes on the x-axis. Because if you're talking about time, you want to be able to see something happening over time. Right? So you want to read it left to right like you read a book. We'll talk about another example later where you could write them either way, but you should write them in the order they're written in your table. You should write them in what order, Wesley? The order they're in your table. Thank you, because if you don't, you will get confused and your data will come out weird and you won't get a straight line, okay? So, our x-axis goes left to right. What should we label it? Rocco, what should we label the x-axis?
We should label it 100 to 500. Or
Ricardo, help him out.
You should count it by 2.
Because we're talking about Adriana.
Oh, wait a minute. Let's do the
Hours. These numbers will tell us hours. These numbers will tell us what? Say it. Nope, up top. Whoa, Columbia, give me 5. Let's try that again. More green than blue, give me 5. Nice, hands down. So, these numbers will tell me hours because hours is our x value. These numbers will tell me miles because miles is our y value. So for hours, let me write miles. For hours, we're going to count by twos. I'm going to zoom in so you can see. Yes, ma'am? I always start with a 0, exactly, because this part where x-axis and our y-axis come together, that's called the origin. And at the origin, the ordered pair is 0, 0. Now, we have to space our numbers on the axis the same distance apart from each other. I'm waiting for the humming to stop. Who's humming? Making me crazy. Stop. Okay, so we're counting by twos. Can I write a 2 here and then a 4 here?
No.
Why? Persephone? Ah, because I skipped a line here, so I have to skip a line here. If I'm going to go ahead and commit to skipping a line, I got to do it every time. They have to be the same distance apart. Okay? So, skipping a line, skipping a line, skipping a line, skipping a line. Now I'm going to label them 2, 4, 6, 8, 10. You don't have to skip lines if you don't want to. I find it easier because you don't have to write teeny tiny. Now, I'm going to move up my y-axis. I'm going to go ahead and skip lines again. And this time I'm counting by hundreds. 100, 200, 300. Let's go ahead and fill in the rest of the ordered pairs. I point to it, you tell me what goes there. 4, 200. 6, 300.
8 and 400.
And
10 and 500.
perfect. Let's plot the points on our graph. Adriana?
Also say, because I learned this kind of off the graph, does that have to be in the line, with the input dot?
Yes, we're going to get there. Not all graphs have points that you can connect with a line. The ones that we're working with today will. Okay? So if I'm traveling for 2 hours, how far does the train go? 100 miles. So I start at 2, I go up to 100, there's 100, and where they meet, I draw my data point. Yes, sir.
But how do you get 2,100?
Where you, oh, no. It's not 1,000. This means 2 for the x value, comma, y value. So it's written like this. Yeah, good question. It's written like this. X value, comma, y value. Okay? So, next one. If I travel for 4 hours, the train goes how far? So I go up to 200 from 4. There's 200. And there's my data point. Do I have to draw lines every time? No. It is helpful. Yes, it is helpful. So do that if you need to. 6 hours, I travel how far? 300 miles. 8 hours? And 10 hours?
500 miles.
Now I can connect my data points. Nope. Okay. And guys, that's lesson 14.
What else?
Okay, lesson 15 says, a synthesis of representations of equivalent ratio. What does that mean? What is a synthesis? What are we doing in this lesson? Can you tell me from the title? Davian? Representations. Yes. Do you think there's a reason why I wrote everything we've learned about how to represent ratios on the board?
Yes.
Julie, what do you think? What are we going to do in lesson 15? Pretty much. Okay, a synthesis, we're just synthesizing or putting it all together and using what we know to solve the problems in lesson 15. So, some of these you can use whatever method you want. The first few that we're going to do together do ask you to use a specific method, so we always have to pay attention to what the question asks. You know at least 5 different ways to deal with ratios, to represent them, but always pay attention to what the question asks for. Okay, so at the end of this morning's news segment, the local television station highlighted area pets that needed to be adopted. The station posted a specific website on the screen for viewers to find more information on the pets shown and the adoption process. So they're like, here's this really cute kitty and here's this really cute doggy.
Ooh, I would
And
like
you
them.
you can totally adopt them. Go to this website to learn more about them and how to adopt them. So the station producer, after they showed that website to everybody, he checked the website after 2 hours and he saw that the video had 24 views. Oh, hold on, that sounds like a ratio. After 2 hours, the video had 24 views. Right? After an hour after that, the website had 36 views.
Gracie,
Yes, ma'am.
do you have Adriana Garza?
Yes.
You sent it to the French teacher
Sure.
today.
Sure.
Thank you.
Thank you. Adriana, please watch the video later, okay? Okay, so. Huh?
I thought she was gonna say attendance.
No. Okay. Nope. I'll wait. So 1 hour after that, it had 36 views. What's 1 hour after 2 hours? 3 hours. And how many views did it have?
36.
So here's what we know from the situation that's set up for us, okay? Now we can move on to exercise 1. Exercise 1 says, create a table to determine how many views the website probably had 1 hour after the end of the broadcast based on how many views it had 2 and 3 hours after the end of the broadcast. Using this relationship, predict how many views the website will have 4, 5, and 6 hours after the end of the broadcast. So, exactly, we're just drawing a table. I'm going to draw mine up and down. You can draw yours any way you want. We're talking about hours compared to views. And it asks us to find, bless you.
Thank you.
It asks us to find out how many views the website probably had after 1 hour. So we want to know 1 hour. We do know that after 2 hours it had how many views?
24.
And after 3 hours it had.
36.
Then the question asked us to find 4, 5, and 6 hours. So, turn and talk to your neighbor, fill in the rest of the table.
Bro, okay.
Fill it in. You should have a pencil in your hand. Okay. Okay, track me in 3, 2, and 1. Now, I'm going to point to it. You're going to tell me what goes there.
12, 48, 60, 72.
Nice. So, in 1 hour, it had how many views?
12.
In 4,
48.
5,
60.
and 6.
72.
That's all the times that the question asks for. We are done with exercise 1.
Wow.
Nope.
Oh.
I am happy you're excited about math, but we have a lot to learn. Track the board. Exercise 2. What is the constant number, which we call C, that makes these ratios equivalent? What's the value that they have in common, Leilani? What's that constant number that we use to fill out the table?
12.
Yes, say it loud.
12.
12. 1 times 12 is 12, 2 times 12 is 12, 3 times 12 is, 2 times 12 is 24, 3 times 12 is 36, 4 times 12, right? It's always times 12. Yes, ma'am. Yes. So, we're going to use an equation, just like we did yesterday, to show the relationship between views, V, and hours, H. The number of views equals what as an equation? Turn and talk with your neighbor.
V equals 12C.
You should not have a C in your equation. You're working with views and hours. It's okay. Okay, bring it back. And who thinks they know the answer? Jeffrey, what did y'all get? V equals what times H? What times hours gives you V? Shay?
We did 1 view equals 12 hours.
Yeah, 1 view is 12 hours, so views is 12 times hours. What if I wanted to find the number of hours? Tony?
You're going to put 112.
Mm-hmm. Yes. If views is 12 times hours, then hours is 1/12 of views. Yes, sir. Yes, you may. Excellent. So, exercise 3. We need to use the table created in exercise 1 to identify sets of ordered pairs that can be graphed. So, you're just looking at the table that we made right here. No, we're creating ordered pairs. What's the first ordered pair you can create from that table? Rihanna, what's the first ordered pair you can create? 1/12. And then, what, Dasani? What's the next ordered pair I can get from the table? Quickly. Yes, 2, 24. Then what, Kevin? Uh-huh. Yes, be confident. Michaela, what's next? Yes. Yes. Next, Davian.
Wait, did we already do 5?
No, look.
Oh, 1.
Uh-huh. And then 6, what, Rihanna?
72.
Mm-hmm. 7, what, Ricardo?
7 1184.
8 what, Wesley? Yes. 9 what, Javier?
108.
Yes. And 10 what? Say it.
120.
Good. Okay, let's plot all these data points. Go ahead, Davian. Okay. Remember our x value was what? What usually goes on the x-axis if you have it in your problem, Jordan?
The one on the left goes on.
Yeah, the one on the left of the table or time. Whatever's describing time. So in this case, it's hours. And up here, we're describing what? Go ahead.
It's miles.
Miles. And that's our y-axis. Now we need to label our axes. Which is that's the plural of axis. Axes. One axis, two axes. Okay. Oh, I'm sorry. I'm jumping ahead or jumping back to the train problem. Thank you. And Itzel, was that what you were going to say? Thank you. Okay, so for hours, we're counting by what? What are we counting by?
12. Wait, no, ones.
Ones?
Twos?
We're counting by ones.
Oh, okay. You just scared me.
Yeah, sorry, I like to trick you. Okay, so let's use what we've gone up to so far. And we're going to count by what up here? What? What am I counting by, Michaela? 12. Make sure you write neatly so that you don't lose track of what number is on which line. 90. Go ahead and plot your data points. Now, is it necessary to plot every single one?
No.
No, it's really not. Because we're going to draw what?
A tape diagram? Oh, no.
I love that your mind goes there. A tape diagram. Let's start a tape diagram. What are we going to draw? Once we, yeah, we're going to use, no. Somebody said a line. We're going to draw a line to connect them all. So we don't really need all of them. Let me pick two that are kind of far apart. So I'm going to do 2 and 24. I'm going to do 7 and 84. That's really all I need to draw my line. Okay. Go ahead and plot your points, draw your line. And when you're done, look at exercise 5. Huh? You don't need it. You have the ordered pairs. So exercise 5 says, predict how many views the website will have after 12 hours. Use at least 2 representations. I'm going to underline that so I don't forget. I have to show 2 ways. So we can use a tape diagram, a table, a number line, right, to justify your answer. So how many views after, how many hours does it want us to find? Yes, ma'am? Go ahead. How many hours does it want us to find, Ricardo?
12.
12 hours. Okay. What do you want to use? What do you guys want to use? Tape diagrams? Cool. Okay. So in, let's do hours and views. So in 1 hour, we have how many views? 12. 1, 3, 5, 7, 9, 11, 11, and 12. Now, if this stood for 12 hours, then every unit would be worth 12 hours, right? And how many units do we have in views? 12. So what's 12 times 12?
144.
So in 12 hours, we'd have how many views? Yep. Let's use our graph to find this number. Well, we have 10, so let's go ahead and count up to 12. Here's 12. If I move up on my line for 12 until I find where it meets the line I drew, then I just move over to the to the y-axis, count up by 12s. So what can I write next? 120, 132, and then
144.
Oh, looky there. Same answer. So we've used a graph now to find the answer. Could we also use a table? Yep. We kind of already started that, right? Hours and views. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Tell me what goes here when I point to it.
12, 34, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144.
And we found it again. Yes. So we used 3 ways, right? We did a table, we did a tape diagram, and we used the graph. Now let's look at exercise 6. So for exercise 6, this is where you really get to synthesize everything or put it all together. Go, yes. Now, a chef from a local Italian restaurant demonstrated how he makes fresh pasta every day for his restaurant, okay? And here's his recipe. Now, what it asks us to find, though, is the ratio of the number of tablespoons of water to the number of eggs. So I don't need the whole recipe. I need what, Dasani? Tablespoons of water and number of eggs. So I'm going to circle those two. That's all I need, right? Let's move down to the next part. Provided the information in the table below, complete the table to determine ordered pairs. Use the ordered pairs to graph the relationship of the number of tablespoons of water to the number of eggs. So if I have 2 tablespoons of water, how many eggs do I have?
3.
3, that's what my recipe tells me. Is there a multiplicative relationship here? No. Not with a whole number, no. No. Multiplicative means to multiply. Yes, ma'am?
On the number of eggs.
Okay. Yes. So, Cecilia says we counted by 2's on this side. So on this side, there's no multiplicative relationship, so we should count by 3's. And she's exactly right. 3,
6, 9, 12, 15, 18.
Good job. Now we have to write the ordered pairs. 2,
And 3.
4, and
6,
6, and
9,
8, and
12,
10, and
15,
12, and
18.
good. Now here's the problem I talked about earlier, where if we didn't already have our table created, you could create it with eggs or water first. That would be up to you. We don't have a variable for time, so we don't really need to keep it on the x-axis. But because they've already put tablespoons of water in the left column, we're going to go with that being X so that our numbers are already in order for our ordered pairs. So down here, I need to count by what? Twos, because I'm counting tablespoons of water. Okay, I'm going to put TBS for tablespoons. Now, 2, 4, 6, 8, 10, and 12. What do I need to count by on the y-axis? Judas. I counted by 2's here because I'm talking about water. So for the y-axis, I count by 3's because I'm talking about eggs. So 3, 6, 9, 12, 15, and 18. Do I have to plot every single value? No. I can say 2 and 3, 6 tablespoons of water, and 9 eggs, 12 tablespoons of water, and 18 eggs. And I can go ahead and draw my line. What would you have to do to the graph in order to find how many eggs would be needed if the recipe was larger and called for 16 tablespoons of water? What would I need to do, Jeffrey? Devin, what do I need to do if I want to find 16 tablespoons of water on my graph so that I can figure out how many eggs I need? What do you mean go up? Yes, because we counted by 2's. We need to count up to, do we? 16 tablespoons. So 2, 4, 6, 8, 10, 12, 14, and 16. Now I go up from 16 to find my line, and then over to my y-axis to find the answer. But over here, I counted by what? 3's. So 3, 6, 9, 12, 15, 18, 21.
24.
How many eggs will I need?
24.
You have the next 10 minutes to work at a level 1 with your partner to complete exercise 7.